All right. Are there any questions you want me to go over on the homework? Any homework questions from review? Yeah. Do number what?
Number 3, it's steeper than the slope is greater, right?
It's steeper when the slope is closer to a value of 1. Or, yeah, so the higher the number, I mean, it could be any slope. But if you made it a decimal, like if it was 10/3, that would be 3.3. That's a lot steeper than 1/4. 10/3 is like this, 1/4 is like that.
Okay.
So the higher the if you divide the two, whatever the numeric value is, the whole number, that tells you how much steeper it would be.
Okay, so for number 3, it's 1/3 and then -2. So we're saying 1 is -2.
Yes, because it would be, yeah.
Okay.
The negative 2/3 would be steeper. 1/3 grows at a rate of 1 and right 3. Negative 2 grows at a rate of down 2 and right 3. So I guess, yeah. Right is slope intercept. Yeah.
There's Spanish homework.
See, I know. I was seeing who wanted to take it. Is that yours, Spanish homework, or you got a question? Yeah.
6C.
6C. All right. 6C. All right. 6C. You have 2x plus 6y equals 10. Okay, we want an equation parallel goes to that point. Okay. A lot of talking going on. So I want to figure out what the slope of this line is. So I'm going to solve this for slope-intercept form. All right, so my slope is negative 1/3. So that's also the parallel slope. Agree? And if I use this, I'm going to call this x1 and y1. So if I wanted to find the point slope of it, I'd go y minus y1 equals m times x minus x1. So I get y minus 3, so y plus 3 equals the slope of negative 1/3, x minus 9. Did it say 6C? Find the equation line. Slope-intercept form, so I need to solve for y. So I'm going to distribute the 1/3 over the parentheses first. So negative 1/3 times x is negative 1/3 x. Negative 1/3 times negative 9 is positive 3. Subtract 3 from both sides. So I get y equals negative 1/3 x plus 0, or just negative 1/3 x. So either that or just that is fine. So this is parallel to the given equation. It also contains a point 9 comma negative 3. Other questions from the review?
So back to number
3.
3. We just did this, but this line is steeper. Y equals 1/3 x plus 2.
Okay. So this is 3. So steepness is not saying if it's positive or negative. So if I were to look at this line, plus 2, and from there I'd go up 1 over 3. So it goes up 1, right 3. This one, if I were to graph this one, and let's say I can graph really well, make them. So this, I'm going to go down 2 and over 1. That's a much steeper line than that. This is decreasing a lot faster. This is decreasing at negative 2 over 1. This one is increasing at 1 over 3. So this one goes, this would be like taking 1 step up and having to walk 3 steps, and then 1 step up and then walk 3 steps. This would be like I take the big 2 down step and walk 1, 2 down and walk 1. Okay? So this is steeper. Yeah.
Does that mean that it's always the biggest negative 2, should I get the 1/3?
The absolute value is a larger number than, and it doesn't matter if it's positive or negative. Yeah, question.
Oh, wait, no, I have a question.
Yeah.
It's on a different problem though.
Cool, let's do it.
Can you do 6A?
6A, yeah, is it this one? 6A. So we have the slope of this, and it passes back. Okay, so we want to put this in slope-intercept form, okay? So I think it's best to put it in point slope first. And x1, y1. Let's plug it in. Y plus 2, because negative, negative, equals 5, x minus 3. And then they want it in slope-intercept form, so I'm going to distribute the 5 over the parentheses first. And then I'm going to subtract 2. Do what?
Do the problem in slope.
They just. I thought it said just solve it in slope-intercept. Find the equation line. Yeah, find the equation line. This is slope-intercept form right here. I use point slope to get there, though.
I just use
There's another way to do it where you could solve for b.
this.
Absolutely correct. This is more of the calculus approach, more accepted in calculus to do it this way. So I will always go from point slope to, I won't go back to the slope intercept twice.
So you'll accept both forms of it.
If your answer matches this answer, I don't care how you get there, as long as you didn't look at your neighbor's paper to get it. Cool? Yeah.
With 5A, when it's find the equation of the line to the point, does it matter what form you use?
So if it's just asking for an equation, obviously you have to find the slope. And if you left it in point slope form, you are 100% correct. If you solved it for slope intercept, you're 100% correct as well. And what my point is on that, and it frustrates me a little bit, so let me just run through this real quick. So this is what I mean, okay? So if it says find the equation, doesn't say what form to put it in. Well, you know the slope equation's this, which is x1, y1, x2, y2. So I'm going to go negative 1 minus 5, 1 minus minus 2, so that's 1 plus 2. So that's negative 6 over 3, so our slope is negative 2. You okay with that? So the next step, I would use point slope. This is the go-to. And as soon as you plug into this, you're done if it just says find the equation, okay? So y minus y1. I already labeled this x1, y1. Now it's possible you label this x1, y1, which means there are two different answers, and I know that. But they still yield to the exact same thing. I would call this 100% done. Okay? Now, this is where I want you to be cautious, Johnny. What kind of error might take place here and here? Distributing of what? The negative. Okay? So this is the answer. So let's say you get to that point, but you decide, oh, I'm going to keep solving it. And you decide you want to keep that positive right there because, you know, your mind tells you to do so. And then you solve it. Now, my answer is going to be totally correct as long as I don't make any sign errors. So this is totally correct here. But let's just pretend you had made this error. Okay, you didn't distribute the negative to both. And then you get y equals negative 2x plus 9, which then this becomes a 9 here. And that's incorrect. So I'm docking you a point. So if it says, what's the equation? Give me the equation. Why are you spending longer going through it where you could lose a point? Even though you had this correct, if this is up above and you have this as your circled answer and you have it as plus 9 because you goofed it, minus 1 out of 3. You got to this point, so you did less work. Less work. 3 out of 3. Okay? So my opinion is don't do the extra work unless they ask you to put it in slope-intercept form. Yeah.
So I did a different way. You found the slope, and then I put it into y equals mx plus b and solved for b.
Mhm.
Is that?
Did you get a b value of 1?
Yeah.
Good. You did it fine. So I'm trying to guide you all to here, and I know that Algebra 1 teachers have told you plug back in one of your x and y's and your m and solve for b, which is appropriate, but it's kind of dirty math. Okay? I'm not going to dock you for it. If you get the answer right, I'm totally fine. Again, if your answer matches my answer at the end, again, if you did copy off your neighbor and you did your own work, I'm with you. I'm just trying to forewarn you that this isn't always the best way to do it, even though it gets there. So, and the example I'll give you is, you all have learned the quadratic formula. Yes? This is totally not related to this problem, but so there was a big movement a few years ago to why are we teaching factoring when you can teach kids the quadratic formula that works all the time and then show them how to work it backwards. It was just dirty math. Meaning, if you would use the quadratic formula and you wound up getting an answer, x equals 2/3 and x equals 5/7, that means that 3x minus 2 was this binomial and 7x minus 5 is this binomial if you worked backwards. So it's like you're reverse engineering it, but you're not really. It's a really cruddy way of doing math. Okay? So the y equals mx plus b, though it gets you the answer, the reason your teacher showed it is one less thing to remember. Point slope really is a big one to use for future math classes. Okay? Any other questions on homework? We good to go? Okay. Let's go ahead and pass those up. Make sure your name's on them. Also, a couple of you have quizzes that you have completed. I just haven't graded them yet. I ran out of time this morning. Sorry.
May I study this tonight?
Yeah, you might not really need that. So I got a whole nother form that comes with it. But it's up to you if you want to.
Is it okay if I turn it
I haven't decided that far yet. All right. Let's do some notes. Get on back. All right. The distance between a point and a line. Develop and understand how to calculate the distance between a point and a line or between two lines. Okay. So you have a line, you have a point. Obviously, the perpendicular is the closest distance, right? So let's see if we can decipher this little. First, quick review. So the distance formula is this. That's the distance formula. A lot of people say it looks like a face. I just know the equation. X1, Y1, doesn't matter which order you label them in, as long as the X's go with the X's and the Y's go with the Y's. And let's plug them on in. So I get -1 minus 4 quantity squared plus -8 plus 3 quantity squared. Agree? And why is it plus 3? Negative or negative. Good. All right, so this becomes -5 squared, which is 25, plus, that's -5 squared, which is 25. So we come up to an answer of root 50, and root 50 breaks down to 5 square root 2 as its best components. How did I get that? 25 times 2, square root of 25 is 5, so 5 root 2. Remember that? May I move on? Okay, if two lines intersect to form a linear pair of congruent angles, then there must be something over here. The lines are perpendicular. Okay, if two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Well, that makes sense. I have this line that comes across. Angles are congruent, linear pair. Then the lines are perpendicular. Sorry. Hopefully. Yo.
For this unit, or for this one, are we going to need to know the names of the theorem?
It's up to you if you want to know theorem 3.8 or if you can just describe it to me. Both is appropriate. Is this okay? Can I move on? If two lines are perpendicular, then they intersect to form, bet you a linear pair. Or right angles. Right? Two lines are perpendicular, then they intersect to form four right angles. Theorem 3.9. You good? Johnny, why are you reading a book that's not related to this class? Bad kid.
Oh, that's an awful
This is really hard.
Alright, if two sides of two acute adjacent angles are perpendicular, then the angles are complementary. Yay! Two sides of two adjacent angles are perpendicular, then the angles are complementary. There you go. If a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other line. If transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other.
We're gonna do proofs as well on these, right?
Oh yeah. Yeah, baby. Sorry, I shouldn't have said anything. You would have forgotten.
Yeah, I know. I was about to say, oh my
I know. Oh yeah, that's right. Thanks for reminding me. Can I move on? In a plane, okay, so ceiling, if two lines are perpendicular to the same line, then they are probably parallel. Are parallel to each other. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. That makes sense. Uh-oh, Ben's sleeping again. We'll try and keep quiet. Moving on. Which segment do you think would be the best to show the distance from the line to the point? Why should that be the distance? All right, so what do you think? If I call this line segment A, this B, this C, this D, and this E, which looks like, and here's our point that we're going from, which one appears to be the closest distance? C? So this is our closest distance? I agree. Is there something I should pull out here? Distance from a point to a line. Okay, it's distance from point to line. It has to form a perpendicular with it. The perpendicular segment is the closest segment. And if you don't believe me, how would this segment here, from here to here, be a smaller segment than this distance? And it wouldn't be. Not in Euclidean math. Euclidean math means it's drawn on a flat surface. We'll get into conical math, conical geometry later,
Does that mean
where all parallel lines intersect. It's fantastic. Takes everything you've ever known about anything and just ruins it. But it also has to do with how the curvature of space works, and you can talk about warping time and stuff. It's pretty cool. It gets out there. It's like total Star Trek goofy stuff, but I love it.
Are we gonna play Kahoot about that?
Kahoot about it? Yes.
Nice.
Dude, we should do Kahoot every year.
You got it. It's fun. Was this the class that was some of the names were Stirrup is bald? Stirrup has no hair was the name. My next period, they're just being malicious kids. Stirrup's a dork. Stirrup can't do math. I mean, I had some horrible names up there. I mean, I like cried. I cried myself to sleep. But it was really, I cried myself to sleep because my wife didn't let me have any ice cream. But, you know, still. All right, just kidding. What should we use for the distance between parallel lines? What should we use for the distance between parallel lines? So really what we should use is some sort of perpendicular. So some sort of perpendicular to those lines. The two perpendiculars would be the shortest distance. That's the shortest distance between those lines as long as they're perpendicular. Okay? Distance between parallel lines. Woo, look at that. I feel like there's something I should be pulling out of the wall on this one. Oh, yes. There we go. The length of the perpendicular segment between them. Is there anything on the last one? The length of the perpendicular segment between them. That's the shortest distance between two perpendicular lines. It happens. It does. It really does. Should I move on? All right. Find the distance between 4, 1. So 4, 1, this point right here. I want it to be blue. So 4, 1. And this line. Okay? So we wanted to find the distance. So the shortest distance is indeed perpendicular. Agree? So what is the slope of this line? 1. What is the perpendicular slope going to be? -1/1, which is just -1, correct? So let's then do this. What can we do? Y minus y1 equals m times x minus x1. Call that x1, y1. Y minus 1 equals m x minus x1. Oops, that should be 4. Okay. Well, that's my first step. So then maybe I could say this. -1x plus 4, which is the same if I solve this, plus 5. So that I'm just looking for the linear equation of this. So this is the linear equation. Y equals -x plus 5. So this would eventually cross up here. What point does this right here appear to be? Two comma 3. So 2 comma 3. All right. Well, maybe we should have done this way: 2 comma 3 and 4 comma 1. So x1 y1, x2 y2. So So the distance is the square root of the difference in the x's plus the distance in the y's. So that's 2 squared, which is 4, plus negative 2 squared, which is 4, so square root 8. Square root 8 breaks into 4 root 2, which is 2 square root 2. So this distance right here is the distance 2 square root 2 in length. So I didn't necessarily need to go find that equation. It was good that I did, because I was able to see the intersection clearly was that, and I think if you have a good grid, you should be able to figure this out pretty easily. That would make sense. I like that. That's a good problem.
How did you get the y equals
Y equals negative x plus 5. I found the linear equation of this line. So I knew the perpendicular slope is -1, and I had to go through this point. So I used the perpendicular slope at that point. Yeah.
So, like if you didn't have a graph, how
It'd be a little tougher.
would you always give us a graph for this?
I'm going to say yes, because I'm thinking how I might solve it without a graph. I don't know yet. I'm trying to get it in my mind I'm just trying to think, how can I make that jump with you guys? But let's see, it might be on the next grid. I don't know. Next time. Can I move on? Steps for, okay. Let's see what the next one just says. Okay. All right. Steps for finding the distance between point and a line. I bet you I could pull this. Whoops. Come on. Find the equation for the line that is perpendicular to the given line and passes through the given point. Is that what I just found? Did I find the perpendicular equation? So I had to find the slope of the original line, find the negative reciprocal of the slope for the perpendicular, and then use that point. And then the second step, solve the system of equations created by the two lines. Find where the point and the two lines intersect. Okay, we had a graph, so graphing is solving the system. Okay, graphing's not always the best, so maybe we could think about using the elimination method or the substitution method. That might work as well if we didn't come out real clear. And then our third step is find the distance between the 2 points. Gotcha. And that's essentially what we did. We did solve the system, but we used graphing in order to solve it. Find the equation of the perpendicular, got it. Solve the system. So we used graphing on the last one, but we could use other ways. Substitution or elimination. And find the distance between the 2 points. Okay. May I move on? So while the rest of you are copying it down still. I need advice. Is there any soccer players in this room? Guys or girls? Okay. I have a girl on my team who has, in the past 2 games, 2 assists for a score on my goal. So, 2 games ago, she passed it right to the other team right in front of our net. Rather than clearing it outside, she cleared it inside. And I'm not quite sure, other than me going, what part of pass it out to the sidelines are you not comprehending? And it does not go in front of the net to get to the opposite sideline. Okay, coach. And so this game, this past Saturday, we got an own goal because of her. She passed it so hard back to a girl that was next to the goalie that the girl next to the goalie put her leg out and bounced off her leg right into our net, which it was my player. I don't know what, I am like beside myself with this kid going,
how can you not comprehend what's a good pass in front of the net and what's a bad pass? And I've tried telling her there is never a pass in front of our own net that's ever good. Okay. No. I mean that. Sounds good. Any ideas? Venture?
Yeah.
No, I make her striker and then put something that put a mark next to the other goal so that she'll know.
Put a teddy bear?
Yeah,
Here, put a
something
stuffed animal.
So
They're
she-
13-year-old kids.
I know, but you know those
Oh, they're 13-year-olds.
Yeah, I put those on my nets when I was like, when I played when I was like 6. They would put the things that blow in the wind on the net so we know which one.
That's the one.
I start playing hockey.
She's 13.
And the sad thing is, she is my leading scorer. Well, she's my leading scorer two ways: leading scores against us and leading scores for us. I don't think that you should be both. Oh,
Yeah, just tell her to stay like on the other side of it.
Yeah.
Yeah.
We just make her
Play
go.
your striker.
Yeah.
What position is she?
she's a right midfielder, and I keep her at right mid because she is lightning fast.
Yeah, she'd be a B striker. Put her as
No.
Every
She-
time
she
she
has
does
like-
that, makes her
she
do like
like-
100 push-ups.
You got it. That might be a good one.
Maybe like 500.
Is she a righty?
500.
Is she
Maybe you should just shave her eyebrows off or something. That'll teach you.
Is she right footed?
She's both.
Oh, then put her left.
I've done her on left mid as well. Left mid, right mid, doesn't matter.
Any mid?
Any mid. All right. Find the distance between. Find the distance between. All right. So let's figure this out. Shh. What is the slope of this line? 3. So the perpendicular slope has got to be negative 1/3. Yay. So I'm going to go y minus y1 equals m times x minus x1. So I'm finding the perpendicular line. So I'm going to get y minus, I'll label this x1, y1. Y minus 2 equals negative 1/3 x plus 6. Agree? Distribute the 1/3 over the parentheses. What's that, minus 2? And then add 2 to both sides. Plus 0, right? So we don't have this graph, so now we got to solve this algebraically. So maybe I could substitute this into here, and we're going to figure out the x and y components. So I get negative 1/3 x equals 3x minus 4. A really good way to do this is clear the denominator, so let's multiply everything by 3. And then I'm going to subtract that, so I'm going to get negative 10x equals negative 12. So x equals 1.2. And then I have to find the y component. So let's see, that was the same thing as 12 over 10, right? Which reduces to 6 over 5. So x is equal to 6 over 5 or 1.2. I think the 6 over 5 might be better. So if I take this x value and plug it in here, I'm going to find my y value. 6 over 5. 1, 2. So y equals negative 2/5. So my ordered pair that's going to go along with this is 6 over 5, comma, negative 2 over 5. So now I'm going to label this x2, y2. And I can find the distance between. So this is between, I might want to call this 1.2 and this negative 0.4. These are the same. And then find the distance between them using the distance formula. What do you think? So negative 6.2. Negative 6.2 and 1.2 and negative 0.4. So x1, y1, x2, y2. If you have a calculator, this would probably be good. The distance between them.
Okay.
Talk to me. Talk to me what?
I didn't Yeah, x equals 1.6.
I subtracted 9x, I made a negative 10x. Right here. And then I divide each side by 10. So I get 12 over 10. 12 over negative 10. Or negative 12 over negative 10. Negative over negative is positive. 12 over 10 is 1.2. Or 6 over 5. I didn't know how we'd use it. Let's see. 1.2 minus 6, that's plus 6 squared plus y2 is negative 0.4 minus 2 squared. Ruh-roh. I need help in more than one way. 7.2 squared plus negative 2.4 squared. So what did you get here?
51.84.
Uh-huh.
And plus negative 5.76.
Add those together.
And so that would be
57.
It would be 7.589.
589, you say?
Yes.
All
Oh
right.
no, that's the answer. No, 57.6 is what is.
57.6 is right here,
Yes.
and the square root of that is
7.59.
sweet. So the distance between our line and that original point is 7.59. So there's kind of a lot of steps that progress with this event. Where are we at on this bad boy? Almost done. All right, almost there. How would our steps change if we need to find the distance between two parallel lines? First, find the single point on one of the lines, then follow the same steps out as before. So find a single point on one of the lines, then follow the same steps. Where's this at? Next to the last one. So find the distance between those. They're parallel, yes? Same slope? Now you're like, well, how am I supposed to find a point on the line? I don't know. Let's pick this equation here. Let's plug 0 in for x. If I plug 0 in for x, what do I get for y? 5. The slope of this is negative 2, so the perpendicular slope is half. Yes? So I get y minus, and this is going to be x1, y1. Y minus 5 equals, what's that now? 1/2 x minus x1. Oh, sweet. I'm going to take this, and I'm going to plug that in right here. Let's clear the denominator, multiply everything by 2. So that's 1x, which is x, plus 10, equals negative 4x, minus 20. That's 5x. Negative 30. X is equal to negative 6. How do I find my other point, or my y component? Plug that back in to either one, it doesn't matter. So let's plug negative 6 in right here. Half of negative 6 is 3. Half of negative 6 is negative 3, plus 5. So 6 comma 2. So I'm going to find the distance between here and here. Yay? Using the distance formula. Oh, this is so cool. This is cool math.
That's the distance.
Huh?
That's the distance.
Well, I'm going to find the distance using the distance formula.
Yep.
Are we gonna be able to use calculators on the test?
Yep.
Okay.
Sorry.
Tomorrow, but not on this. Yeah.
Did you get 2?
Huh?
Did you get 2 for the last one?
I plug -6 right here. So half of -6 is -3. -3 plus 5 is 2.
So here it is.
All right. So, guys and gals, there's a quiz tomorrow, 3.4 and 3.5 quiz. Due Wednesday is 3.6. 4 of these distance problems and 9 review ones. Okay. Chapter 3 test on Friday, October 21st. That's all the information you could ever want to know about my class, plus some. What time are we out of here? Do you have time for who?
What?
You're not going to be here tomorrow?